Okay, guys, this is the Pythagorean Theorem lesson 2. The question is, what is a Pythagorean theorem and how does it work? And for this one, you're going to explore the Pythagorean triples and understand how they work. So your do now is, what is a Pythagorean theorem and how does it work? So I went ahead and just wrote the answer there. Pythagorean theorem is in a right triangle, the square of the hypotenuse, which is a new word for you guys. That's the diagonal that we worked on in the last lesson. This part right here is called the hypotenuse, is equal to the sum of the squares of the other two sides. So if you have that same triangle we were working with in that last lesson, you've got the height of 4, the base of 3, and now the diagonal of 5, which we're now calling the hypotenuse. So if you take 4 squared plus 3 squared, so it's the sum of the squares of the other two sides. So 4 squared is the square of one of the sides, it's 16. And 3 squared is the sum of the other side. So if you take the sum of that, 16 plus 9, it's the square of the diagonal, or what we're now calling the hypotenuse. So if the diagonal or the hypotenuse is 5, square it, that's 25. So if you add 16 plus 9, that's 25. So the theorem, or the equation, is of Pythagorean theorem for right triangles is a squared plus b squared equals c squared, when this is a, this is b, and this is c. And these two can be switched because of the commutative property. You can flip those around, it doesn't matter which one you have is a or which one you have is b, as long as c is the hypotenuse, the diagonal that connects the two legs of the triangle. So your question number 1 is 3, 4, and 5, which we've been working with, is a Pythagorean triple. What do you think a Pythagorean triple is? And if you printed out this lesson or took a look at it, I included a list of very popular Pythagorean triples. So Pythagorean triple is a set of 3 numbers that fit the equation perfectly. A squared plus b squared equals c squared. So let's just come up with 3 random numbers and see if they work, okay? So I'm going to use 2, how about something that we haven't used, 6 and 9. So I'm going to say this is A, this is B, this is C. So 2 squared plus 6 squared equals 9 squared. So 2 squared is 4, 6 squared is 36, 9 squared is 81. Does this work? 4 plus 36 does not equal 81. So 2, 6, and 9 are not Pythagorean triples. They have to fit perfectly. So let's play around with those. I think for question number 2, the Pythagorean triples that we're going to use here aren't actually listed on this list, but let's prove to make sure it works. So these next 2 questions are pretty tricky. You kind of have to use your spatial skills to figure out how to draw the triangle. So Mrs. Bartlett is teaching in a 5th grade class. She is standing 12 feet from Danny. So if this is Mrs. Bartlett and this is Danny, they are 12 feet away from each other. Sasha is sitting 9 feet to Danny's right. So here's Danny, and here's the right of Danny. Here's Sasha, here's the 9 feet. How far apart are Mrs. Bartlett and Sasha? So here is my hypotenuse, or my diagonal, of Mrs. Bartlett and Sasha. So we have to figure out what is C. So using this same equation, let's go ahead and do this. So 12 squared plus 9 squared equals c squared. Here's my 12, here's my 9, here's my c. So 12 squared equals 144, 9 squared equals 81, and we still have c squared over here. So 144 plus 81 is 255, still c squared. So we want to figure out what times what equals 225. So we're going to find the square root of 225 to figure out what 1c is. So the square root of 225 is 15. Therefore, c equals 15, and Miss Bartlett and Sasha are 15 feet apart. Okay, so this next one is actually listed on here, but we're going to prove it mathematically. It is this one right here. So your answer is going to be 13, but we're going to, or 12. Your answer is going to be 12, but we're going to prove it mathematically. So Diane, this one is tricky. Diane would have to drive due north. So here's Diane, and she's driving due north, right? Straight north. to get to her parents' house and do east, that's east, to get to her grandparents' house. It is 5 kilometers from Diane's house to her parents' house. So from Diane's house to her parents' house, it's 12 kilometers. And, excuse me, parents' house, and a straight line distance of 13 kilometers from her parents' house to her grandparents' house. So from her parents' house to her grandparents' house, it's 13 kilometers. How far is Diane's house from her grandparents' house? So you need to figure this part out right here. All right, so if this is A, this is B, and this is C, we got to figure out what B is. Now, we already know, according to our Pythagorean triples, that it's going to be 12, but let's prove it. So we're going to use A squared plus B squared equals C squared. So let's plug these numbers in. 5 squared plus B squared, we don't know, equals 13 squared. So this is 25. Still leave that in there. And I think 13 squared is 169. 13 times 13 equals 169. 169. I got to get this B squared all by itself on this side of the equal sign. So I'm going to subtract 25 from each side using algebra. Equals 144. Oh, I know that number. So now B squared equals 144. Now I need to figure out what B is. So what times what is going to equal 144? So to do that, I find the square root of 144. So B equals the square root of 144. Therefore, B equals 12. Did our Pythagorean triple work? Yes, it did. Therefore, 5, 12, and 13 are Pythagorean triples. And there's a whole list of them, and if you want, you can practice proving these using A squared plus B squared equals C squared. Now, in your Pythagorean triples, the last one will always be listed as C, okay? The first two you can flip around. You can make this one A, this one B, or you can flip around and this can be A and this can be B. You're still going to get the same answer because of the commutative property. I will hopefully post the answers to the Walk to Math Measurement Formula assessment this weekend. You guys can go ahead and print that off or make a copy of it and do it online. And then you don't have to send it to me or take a picture of it or anything as of right now. You can just check your answers on it and then shoot me any questions over email that you might have about any of them. I know some of the questions may be tricky because there's not a drawing of something. I'll go through that and kind of clarify it and add anything I need to. All right, bye-bye.